Hi, welcome to another edition of DesignSpark Ask the Expert. Today we're going to be talking about test and measurement, digital multimeters, and today I'm talking with Fluke, and it's their 75th anniversary this year, so what better time to be talking with Fluke? I've got Mark from Fluke. Hi Mark, do you want to say hello to DesignSpark?
Yes, hi Greg. Thanks very much for having me on, and welcome for the opportunity of coming on to DesignSpark to have this discussion. Thank you.
Fantastic. So when we think about a multimeter, there's a lot of things to consider, particularly with digital multimeters, but I want to just go back to the beginning. Maybe we start with analog and we explain what the difference between a analog multimeter and a digital multimeter is. Could you just give us a few kind of pointers?
Sure. Yeah, no problem at all. Well, when we talk about multimeters, obviously, which is where Fluke pretty much set it stand out from the very beginning, analog was obviously the current status at the time of inception. What people took away from an analog meter was that the movement of the needle itself. So people were looking for movement across there. And again, for indication of variables, if you like, that needle would move and give the slightest of adjustment there. And that would be enough for the customer or operator or user, if you like, to get sufficient away from that. But obviously, as time and technology has progressed, obviously we've got liquid crystal displays, LCDs displays, and then we're able to obviously now go down to a more digital method where you can get much more levels of higher accuracy with that. So yeah, evolution has just meant we've moved away from that, but there'll still be some traditional electricians out there that like to see an analog display in conjunction with a digital display as well.
Absolutely. And just for many engineers, for example, the digital multimeter is their go-to piece of test equipment.
Sure.
And as you mentioned, over the years, the functionality has increased significantly. So if we think now what we can measure with a modern digital multimeter as opposed to in the past, what are the what are the things, the functionality that we are actually seeing now with a digital multimeter?
Okay, well, that's a very good question. Obviously, multimeters have evolved, as we just said there. Traditional measurements would be ampage, voltage, and ohmic resistance, basically, as well. So those would be the sort of typical measurements that the founding multimeter would have. But obviously, as we've found more technology, if you like, we've started to add things like temperature, capacitance has gone in there as well, frequency, duty cycle. Temperature, like I say, and then we've even got multimeters now that have logging capabilities and logging function in there as well. So whilst we've maintained the core there of the volts, amps and ohms, we've obviously started to add much more functionality there, and it obviously enables people to carry out a much wider range of measurements across their individual applications. So
Great, fantastic. So, for as long as I've known, Fluke have been the market leaders in this space. And I remember when I got my first Fluke, and like many engineers, we've come to rely on Fluke over the years. Um, but in terms of your current offer, what is it you guys have available for users in a digital multimeter?
okay, well, I, when I sort of get this question, and obviously it comes a lot, that, as you say, Fluke is pretty much synonymous with the leading brand or global leading brand, I dare to say. And we've always been of that mantra. And John Fluke, who's obviously the founder of the business here, if you like, he was always adamant that he wanted to give the customer or the user of the equipment a little bit more in the product than what they actually paid for. So we always found that the value that you were going to get was give you a little bit more than you actually expected. So, and that even carries on today. Our new product and our new mantra is to basically work the future together. So basically what we're trying to do is just work with our customer base, if you like, work with our channels, work with people out there in the market, and just constantly evolve with them and give them much more than they think they actually need. So Fluke itself has always operated around a few core elements. This is by giving people value for money, obviously, in the product. We want the meter to be accurate. We want it to have good durability and reliability across it as well. We want it to be fit for purpose over a number of years. So again, to offer that, that comes back to the original, that we just want to offer people a little bit more than what they actually expect. So from that, we offer a wide and extensive range of multimeters for every individual application, depending on what they might need.
Yeah. So exactly what you said, offer a little bit more than what people expected, is certainly how I view Fluke test equipment in general. But if we look at the kind of the electronics market, the electrical, the industrial environments, we're talking about major differences in the amplitude of measurement values. For example, like volts, frequency values. How does a multimeter stack up against this? And is it possible that one multimeter can operate across all of those fields?
Right. Okay. Again, probably the nicest way to answer that is that Fluke like to believe that we have the right product for each application. And with that of mind, what we've done is we've broken this down into a way of which the application or the user can operate through a selection guide on how to find the right meter from him for his personal needs. So from that, and just to expand on that a little bit further, we have a 110 series, which was what we would class as the entry-level multimeter for, I don't like to say general purpose, but it is classed as the general sort of multi-purpose multimeter. So for somebody that's going to need some basic measurements, as we said earlier, of volts, amps, ohms, etc. And then that range expands out a little bit further. Then we move to our 170 series, which then starts to lead towards more industrial use and utility type use, where they might need a little bit more accuracy. They might need a few more extra levels of functionality. And then we move again higher up to the 280 series and the 80 series. And again, these are all operating the same measurements. It's just the accuracy may improve with them, the durability and the safety ratings as well, which is something that I'm sure we'll talk about as the session goes on. But for primarily, we like to think that we have a multimeter specifically in line with what the customer actually needs to do their specific job function. Again, as you'd expect, with the entry-level multimeters, they're not going to cost the same as the middle order and the high-spec multimeters. So there's always a cost there that's associated. So again, price should never be the issue. It should always be about the functionality and the safety of the meter and the tool for the application it's for. But again, we try and fit something in for every user at a price point that's right for those as well.
Fantastic. I think it's important to look at safety. Obviously, you're talking about additional functionality depending on which meter you get, but at the same time, the base models and against the more feature-rich set models, safety is really important, and it's really important to understand where a digital multimeter is likely to be used. You need to understand the environment, and the products need to have a suitable rating for use within that environment. So can you just help users understand more about installation categories? These are often referred to as overvoltage categories, and just give us a little bit more information about finding out where your meter is likely to be used.
Okay. The easiest, probably the most straightforward answer I can give to this one is that there's a number of standards out there in the public domain that are adhered to by the electrical industry. And one of the most specific ones here is the IEC 61010 standard. The IEC lays down some guidelines here for the safety ratings that each meter should have in order to operate within certain environmental zones. When I say environmental zones, I mean certain operating areas, basically. So for these, they rate the instruments from a Cat 1, Category 2, Category 3, through to Category 4. The short answer for this one is that the Category 1 would be obviously just domestic appliances, if you like, as well. So that one sort of falls into its own niche. But where it starts to become much more, I'll say, sensitive, if you like, to the right piece of equipment being necessary comes at Cat 2. Category 2 is where you would have single phase installations there, where you have appliances or large electrical appliances, obviously, that are operating there that need to be worked on safely. So that applies to Category 2. When we move up to the Category 3, there becomes certain standards there much more relatable to what we would expect. This would be where you may even go from a three-phase system or a single-phase system, but it's there around the commercial nature of things. So let's say lighting and installation, where there's equipment that's in a fixed location as well, where switch gear might even be available and potentially need to be used. So that's what we have a Category 3 rating for those. And then the final one that I'll speak about here is Category 4. Category 4 is the highest level, again, for three-phase, mainly you're operating around the utility sector. This is where you might have outdoor connections, you want much more safety elements taking place. Typical ones would be around your consumer units and electricity units, etc., maybe even service entrances. All these things where utilities are going to be much more need to be tightly controlled and potentially at much higher voltages as well. So that's why these category ratings are important, and aligning with that, making sure that your electrical meter actually is relevant to be used in those specific categories as well. That is the most critical thing there, because again, we're talking about obviously potentially hazardous and dangerous areas where, again, high voltages could be potentially present, and then obviously likewise there's always an element of risk. So these need to be taken strong consideration towards.
Yeah. And I think, you mentioned 6-10-10 there. So it's important to understand, that your meters are rated to particular categories within that standard, and each category has its own set of values for things like, over voltage and transient. And I
Yeah,
think it's important to say, that a lot of the safety is built within the multimeter to make sure that the multimeter remains safe
sure.
and keeps the operator safe. But just for our viewers, could you essentially just tell us what an overvoltage and transient actually is and how do they occur?
Okay, well, over voltages are transients, if you like, are the same thing. What we're looking there is that most circuits operate around a normal nominal voltage, basically, whether that be 600 volts or 1,000 volts, whatever the voltage might be. So over voltage is as obvious as it sounds. It's the voltage that steps higher and outside of those tolerances, if you like, and it basically relates to higher voltages or higher energy above those nominal voltages. These generally can take place by ways of three typical ones, which would be a spike, a transient itself, or a permanent, if you like, over voltage. So each of those are typical conditions that could happen. But overall, it's where you get a high amount of energy for a very short duration. That's typical where we see these over voltages. So it's important that we have a meter that offers that level of protection for those categories to make sure that when they're operating, they have the safety of themselves and the meter and the environment as well. So all those are the most important things to think of there. But again, with this is always on the unexpected, if you like. So that's why we urge people to obviously ensure that they've got these meters rated at the right levels that are necessary to operate on those conditions.
Great. That's just brought back in my mind. I remember when I first started out, I used to work with an old chap, and if anybody ever asked to borrow his test equipment, particularly his multimeter, his
Sure.
first question was, "Do you know how to use one?" Which
Right.
seems strange. But
Yeah.
his second question was, "Where are you going to use it?" So it's important to check the multimeter that you're using is rated for the environment you're in. So in
Yeah.
terms of fluke, where on the meter or the information can you find this?
Okay, well, I've got a couple of meters to hand, so I might as well bring one to the table here for you. So what you're going to see here is obviously the category ratings are going to be listed across the front of it here. That's the first one that you'll be able to see. And on the reverse of the meter itself, on the back of the casing, underneath here, they've got all the typical markings as well from the various standards to ensure that it's actually accurate. But you can see here, there's the ratings, the connections, and everything is clearly stated there. And like we've said here, we're advertising our 75th year anniversary on the front here of our model units. So again, you can see the ratings marked clearly here for the 600 volt or 1,000 volts, depending whether you're working in a category 2, or category 3, or category 4 rating environment, basically. So most important, you utilize these marks, make sure you're using the right meter with the right functionality for the right applications.
Great, fantastic. And we can't talk about digital multimeters without talking about the test leads, particularly when we're talking about safety. So in terms of checking test leads, why is this so important as well?
Okay, well, when I say this one, probably the most straightforward thing I say is I sort of talk about this like a car tire almost, if you like, on the road. What you have to think is the test lead is very much like the car tire. It's the point of contact that you're actually making to the road. So again, with a test lead, obviously we've got a typical standard test lead here. And what it has is obviously this point of contact here is between you, the meter, and the point of electrical source there, if you like, and where that point of energy is. So with the test lead that you have like this one here, you'll notice that they've got a number of safety features built into them. One, they're very durable, very robust. They've got guard protection on them as well. And then on the actual probe itself, the safety ratings here. And on ours itself, we have two models here. This one here is set at the moment for category 4, and it's got a very short exposed tip here because of the energy that could potentially transfer. When we start to work at lower
Hmm.
thresholds, the safety rating reduces here, and you can see much more of the tip is exposed because the potential is not as, I don't like to say as dangerous, but again, it's reduced because you're in a slightly lower category rating. Therefore, you can have more tip exposed because of the voltage that may be present. So again, this is one of the main safety features that Fluke offers, these twist guard test leads exposing or more of the tip or reducing it down for depend on the environment that you're going to be using. These clearly are durable test leads. They have a nice solid right angle here that would connect directly into the multimeter itself. So plain and simple, you can just drop these safely into the meter there with very little exposed and very little exposed tip, giving you the most level of protection that you could have for both the meter, yourself, and your test leads as well. Okay.
Yeah. I guess it's important to also make sure that your test leads are rated to the same capacity as the meter. Is that right?
Yes, 100%. Again, our test leads here have obviously got safety protection built all the way through them. They're fused test leads as well, because we want to protect obviously the user, but we want to protect the instrument as well. So the leads are fuse protected here, and they're diligently tested. When you have your multimeter or any other electrical piece of equipment that takes some kind of measurement, we recommend that the unit would be calibrated there. So with that, we recommend that not only do you have your instrument calibrated for levels of accuracy, you actually have your leads checked and tested as well, because it's very easy as a user to take this into a sort of routine practice, if you like. So not every day does somebody check all the fixtures. They don't check for little breaks in the leads and the cable itself or the termination.
Hmm.
So we strongly urge people to do this, and we know there are diligent people out there, but again, we take this as sort of common practice. So if I could stress anything, it's to get, like you rightly say, the correct meter for the job, rated with the correct safety level, get the right safety leads, make sure your leads are clean, they're not broken, they're not frayed, they're not damaged in any way, and that the tip is exposed to the right level for the category rated environment you're working in. That would be obviously a primary concern for Fluke, to make sure you follow those simple steps.
Fantastic. I do like the car tire analogy. That rings true with me. As being essentially being the weakest link. Your
Yeah,
tires on the road are the first point of contact, which is keeping you actually on the road. So yeah,
yeah,
I get the
exactly.
analogy there. That's a really nice way to explain that. You briefly mentioned accuracy there when we were talking about the meter and the test leads together. So
Yep.
why is it important to consider the accuracy of reading when choosing a multimeter? Is it different between electronics and electrical sensitivity, accuracy? Is that important?
Right. When people talk about accuracy, most multimeters try to adhere around about 0.5% of the measurement that they're taking. That sort of has become pretty much the standard sort of default go-to level, if you like. Now, with some levels of equipment and operating machinery, let's say, that element of drift of tolerance, if you like, away from that measurement there might need to reduce. And the closer you reduce that down to zero, the better it's likely to be. So what Fluke offer is they have a number of multimeters that operate that 0.5% of accuracy there, and they'll come down to 0.1 and below 0.1. The lower you go down and get towards zero, and the more accurate that meter becomes, it removes the element of margin and error basically as well. You're getting as close as you possibly can to a perfect measurement. When you start to reduce those values
Hmm.
down, it then gives you an element of consistency and accuracy and reliability as well. So having a tolerance of 0.5 is good and is probably more suitable for most people out there. But obviously, we offer in our higher spec meters, we'll bring that level of accuracy down to 0.25, 0.1%, etc. And we'll just keep bringing it down because people want to get much narrower margins of error, basically, and get much more reliability and repeatability with it. So that's where accuracy starts to come into its own.
Yeah. So, you're talking about accuracy coming into its own there. So, if we were to say, how reliable is a multimeter for giving a true reading? If we were talking about things like, say, range selection, resolution, and tolerance, or even things around true RMS, what is it you can tell me about that side of the fence?
Okay, well, again, like I'm saying, when you start talking about percentages here of accuracy, if you would think a typical measurement, I don't know, say on a 3 volt range for argument's sake, yeah, so a fairly typical low voltage measurement you want to take, and then you start to have some accuracy, where you start talking about a 1 millivolt range of resolution over that 3 volts. It means that on that 3 volt range, you could be measuring down to 0.001 at that 3 volt range there. So what you're actually getting is a very, very accurate level of measurement on a very small value anyway. So it comes down to what the user actually needs. But again, the higher the range of multimeter that you go up to, you're naturally going to get that level of accuracy. So it's just important to know what you're testing and the level of accuracy that you need here as well. Now, like most obviously manufactured test equipment, Fluke make a clear data sheet on obviously all this, because you'll want to know what the resolution and the accuracy is for ampage, for voltage, for temperature, and everything else. So if we were to say that we
Yeah.
start like we do at 0.5%, and then obviously as we climb up the range, as I mentioned, you can start to reduce that down to 0.01 for argument's sake, and it just obviously gets finer. And like I repeat myself a little bit, it will actually just give you the reliability. The closer and the smaller the margin of percentage is, the much more you'll get reliability and consistency in their measurements. So that's what we're hoping to offer the customer.
Fantastic. I recently did another interview with one of your colleagues about the test equipment used in the solar industry. So one of the things we were talking about was application specific. So if we were to look at the digital multimeter, application specific versus functionality,
Right.
what would you mention to us if you were to take us through a typical selection process when choosing a multimeter? So if we were considering different scenarios for use, you mentioned general maintenance earlier, but if we were looking at things like motor control, three phase, HVAC, how do you start to approach, choosing the right instrument for you?
Okay, well that's a good question, and the easiest way to say this and try and answer it is obviously with Fluke having a number of different multimeters available, as you say, for different applications. We've actually generated we call it a fairly straightforward selection guide tool on the Fluke website. Now, I've got this slide in front of me now, and I'll try and guide you through it as best we can. But when you look at the slide, what you can see here is it offers three basic levels of question. It aims to ask you basically, what kind of work do you want to do? In this instance here, the first primary question to ask here is it basic electrical testing you're hoping to do? Are you looking at doing some kind of advanced troubleshooting or preventative maintenance? Or are you looking at some R&D levels or high levels of engineering? So what we do with the selection guide is we just basically work our way through these and just make some selections. So in the first instance here, we make a selection. So as you can see on the slide in front of you, I selected basic electrical testing. Once we select that, then it offers us another question, and it's primarily asking us, what environment we're working in here, because this dictates the category rating, and the category rating, again, can steer us towards the right meter to be used in that environment. So once we get that, and I've chosen in this instance a category 3 rated instrument, again, once we move through, we've got various bits of testing you want on your application. So are you going to be doing some basic measurement, field work, maybe heat vac or heat and ventilation, air conditioning, electrical, or even some mechanical work? So once you've made that selection, so in this case here, I chose a heat vac one. Yeah. So again, what it's done now is it's steering you to a typical one. And because of this, it's actually just brought us to, in this slide here, the 117. So as you can see here, that one is specifically designed for an electrical engineer there. And it offers a full level of functionality that he could want for that one there completely. So more detailed specs are available, as you can see on the website tool, and you can see you can just click on that one there and pull it down so you can see what obviously additional features and functionality that meter has got. Now, this tool works obviously in many different ways, and it will obviously do its best to take you to the right one, but there may be something else that you'd want to see, like, let's say temperature might be something that you'd want there for the HVAC one, and you can obviously start to look at various other meters as well and various other levels of functionality. You might want something as specific. If you were to say a boiler engineer, you may want some low pass filters put in there as well. So again, just make sure you go through the spec in more detail for that one. Now, as I said to you, there's a complete range of different meters. We've got the 110 series, we've got the 170 series, we've got the 80 series, we've got the 280 series, and then we've got some specialist 20 and 70 meters as well. And again, all of them are there for you to take advantage of and just work the specification and go through that selection tool guide, basically, so you can get the right meter for doing the right job in the right environment.
For sharing that with us. That all makes sense. Just before we finish, so we spoke about digital multimeters, but there is another piece of test equipment which is really, the addition, the I'm going to say not. I'm going to say the little brother to a digital multimeter, but clamps are
Yep.
being more widely used than ever before. There's more functionality now with clamps.
Yep.
So, in terms of clamps for most engineers, could you just explain their primary difference between those and a digital multimeter?
Okay, well, over the years, a clamp meter is typically just, as you rightly said, it's sort of just sat next to the multimeter, if you like, as a sort of big brother or sister, if you like, to it. Now, obviously, I've got a typical clamp meter here as well. So this is one of our latest ones that you can see. Now, again, the most glaringly obvious thing that you see with a clamp meter is the open jaw here. So what that enables somebody to do there is to obviously go around a CT or current measurement, take that without obviously making any direct connections to any test leads there as well. So that's the most important thing. Obviously, it's there for safety, and it gets around obviously much higher amperages as well. Now, over the years, Fluke has made multiple progressive developments with clamp meters as well. And probably the most significant one has been the addition of a Rogowski coil. Now, for those of you who have not seen one of these, this is a typical Rogowski coil. What this does, it allows the user of the clamp meter not just go to 1,000 volts, and 1,000 amps there. What he might want to do is obviously open this up to a much higher threshold. This one here will go up to 2,500 amps. So again, as you can see, it just completely, it detaches away from itself. And then what happens is allows a user to thread it round a conductor. He locks it back into place here. And again, that he can just leave it in situ and step away from obviously that and put himself into a safer position. That connection is joined in, as you can see, at the base of the flex there, and it fits in nice into the base. So it's a nice little additional tool. Now, adding on to the clamp meter that I'm showing you here today is this new bit at the top here. Now, again, it's just highlighted in yellow, and it's got a little voltage signal next to there, a little voltage sign. And what that means there is if you were to get a conductor, and this was your conductor, and just hang it in that top section that's just below there where it's yellow, that will actually take a voltage measurement for you as well, accurate enough to give you that without making a direct voltage connection to the circuit. So again, it's some safety technology there. Now, it's breakthrough. Nobody else offers this as we speak today. So again, you can take your current measurement, but now you've got the ability to take a voltage measurement and obviously get both those results displayed simultaneously on the screen at once. So again, we've just really tried to make some innovative steps forward here for safety and ease for the user to take into place. But to go back to your original, what do we get? A multimeter generally reaches a top end, if you like, of connectivity around 10 amps. These will go significantly higher and record much higher amperages basically across the board there. So that's probably the most glaringly obvious difference between the two meters there.
Yeah. If I just go back to what you mentioned right at the beginning, the ethos of Fluke was always to give the user something more than they anticipated.
Yes.
That's a perfect example with that clamp meter where you can actually now just hang that, take the voltage measurement. Like you say, I don't see that functionality anywhere else other than in that product.
Yep, it is the newest thing that we've offered basically for the clamp meter there. Obviously, it's designed to give the user a pragmatic safety way of testing this as well. Now, it'll never be as accurate at this point in time as what a direct connection would be. But most users today, all they want to know is that there is a voltage present. Don't get me wrong, it's still accurate. It's just not as accurate as a direct measurement of contact would be. But like I say, most people want to know there's a voltage present, and that's the most critical thing there, that you can do that now safely and easily without having to make that connection. So, yes, it's very much the precedence. Yeah. And again, like most things, we'll take the lead, and then we'll wait for others to follow.
Great. And the same with a clamp as a multimeter. Make sure you've got the right rating for the correct environment, etc.
Sure. Again, what you get with a clamp meter here typically is they're generally marked quite clearly across the same. I'll show you again on this one here. Now, as you can see at the bottom here, just where the connection points are, it gives the category ratings there. So it's still category 3, category 4 rated for 600 and 1,000 volts. That's clearly marked. Your terminal points for the test leads are in there, and all the safety standards as well that we've got that are on the back of all of our meters. They clearly show the CL and UL markings here as well to make sure that the meter has been correctly manufactured and tested to the relevant standards. When each of our meters are done, they'll obviously come out with a certificate of conformities, etc., and make sure that they're built and supplied to the highest standards. All our test leads are obviously brand new cased and tested as well before issue and supply. And in most cases, you'll get a case or a tough case with a clamp meter as well to keep all the relevant accessories and probes and leads that come with the meters as well. So, yeah, we're still very much, again, like you've just rightly said for me, we're just trying to give the customer what they need and give them maybe a little bit more than what they actually pay for. So, yes.
That's really great and a fantastic update about Fluke, particularly in your 75th year. So Thanks for joining DesignSpark today, Mark, and explaining digital multimeters and also the additional information around clamps.
No problem at all. Thanks very much for letting me do this session.